At the Gaithersburg Community Museum. I'm so glad you could join us tonight for our virtual skywatching program. Certainly the silver lining to the pandemic is the fact that we've been able to have astronomy programs through the winter, which we wouldn't normally have. And tonight, we're really excited. Skip Bird and Chris Bennett with the Westminster Astronomical Society are joining us, doing some mad scientist comet building stuff and a little actual sky watching. And thankfully the skies cooperated. So we have clear skies tonight, which is really, really wonderful. I just want to say before we start, tell you some of the things that are coming up, and also mention that the activity that Skip is doing, we have actually posted the instructions in the discussion section for the event. So if you feel like cooking up your own comet later, you'll know how to do it. So Tuesday, our Storytime station happens to have an astronomy theme. So we are going to be joined by author and illustrator Yesenia Moises. Her brand new book, just out this month, Stella's Stellar Hair, takes us on a tour of our solar system. And in the discussion for the event, we've suggested how you can make your own model solar system. So if you want to follow along through the solar system with Stella, you'll be able to do that. Then we're just now planning with the Rockville Science Center a series of programs to celebrate the landing of the Perseverance Mars rover. So on the 17th at 7:30, the Rockville Science Center will be featuring a talk with Eric Lalness. He is a designer of instrumentation, has worked on the Curiosity Mars rover, and he's going to talk about some of the instrumentation that is on Perseverance. And then on the 18th, we're hoping to do a landing watch party. And that should be, I believe the landing is scheduled for the afternoon around 3 o'clock, which I don't know what that is Mars time, but super convenient our time. So sometimes these things are really early or really late. So I was happy to hear that. And then that night, Becky Lawrence will be joining us. She is a welder, actually a graduate of Gaithersburg High School, and she is, her company is Aerospace Welding, and she works on making some of these things that go into space. And she's going to talk about what is involved in building something that can withstand the rigors of going into space, like Perseverance. So with that, I'm going to turn it over to Skip and Chris. Please, if you have any questions for either of them, put it in the comment section below the video, and we'll pick it up and we'll share it with them later. And also, once Chris is going to show us some stuff in the night sky, but if there's something special you want to look at, put that in and he'll see what he can do. So work your magic, guys. I'll see you at the other end.
Howdy, boys and girls. My name is Skip Bird. I'm with the Westminster Astronomy Club, and I want to wave to everybody out there, and occasionally things will pop up and wave at you too, okay? Hi. All right. We're going to do a program. I'm going to tell you a little bit about the Westminster Astronomy Club right there and right here, okay? We are the local astronomy club. We do a lot of outreach and programs for the state. So if you ever need anything, you want to do anything virtually with us, want us to do a program for your Boy Scout, Girl Scouts, homeschool groups, birthday party, anything like that, just contact us. So we do all of that. So tonight, what we're going to do in honor of some upcoming meteor showers, previous last month's meteor showers and everything else, we're going to do a program I like to call Chicken Little Was Right. Okay. How many of you read the story Chicken Little? Good. All right, raise your hands. Yep. Chicken Little was running around because things fell on his head and everybody thought he was crazy. Well, things do fall from the skies. This one right here, I'm going to zoom in for you so you can see it. That's a meteor. That's not a rock you found in your backyard. That is a meteor. Okay, it looks like that. Here is another meteor. All right, this one fell in Russia back in a few years ago. All right. This here is not a meteor. This is a meteor wrong. This is a chunk of asphalt from the driveway. So back to the program. All right, now I'm going to need your help, all right? Because as a scientist, as an observational scientist, I observe things. People observe things. All kinds of things happen out there. We want to make sure everybody's observing everything. Sorry, I forgot to start my clock. All right, let me take that. Everybody is, whether you're a teacher, an actor, an accountant, a nurse, a doctor, a kid, your world is observing things, okay? For example, if I say I'm going to put on my hat because I'm going to be your pilot tonight, okay? Make sure your tray tables and seat backs are in the upright position, all right? If I say my hat is blue, you're going to raise your hand and go, Mr. Skip, Mr. Science Dude, your hat's not blue, it's green. Wait, is it green? No, it's brown, see? And if you find me doing something wrong, wave your hand, wave your hand. I'll go, what? And then, okay, do that, right? Because I need help, because sometimes I make mistakes. Right? As a scientist, I'm observing. I observe things all the time. For example, a chemist would take something like this, pour a couple of things in there, and then see what happens. But unfortunately, what he didn't do, he did this to go, you know what, I'm thirsty, I'm going to go down. He runs down to the store to get something to drink. Well, he looks out the window and wonders why all the smoke and fire is coming from. It's because he didn't stay and observe. And a biologist, he's an observer too. Right? A biologist would take a lamb and put it in a cage with a lion and go, you know what, I'm hungry too. So he goes down to the deli. He comes back wondering why there's a really big lamb in his cabinet, in his cage. What happened to the lion? He didn't stay and observe. So that's all a scientist is basically observing and asking why, okay? So we're going to do that. So tonight we're going to make a comet, because comets are giant, dirty snowballs. And what they are, they're the source of all of our meteor showers. We have some upcoming meteor showers, which you can find on our website, and about any other website if you want to go to it, about upcoming meteor showers that are coming up. We're not going to talk about those tonight, but we're going to tell you that's where all the meteor showers come from, is from comets. And comets are giant, dirty snowballs. So I need your help tonight. We're going to make a comet here tonight, a big, giant, dirty snowball. We're going to make a comet, but I need your help because there are hundreds of thousands of chemicals in there. But tonight, since we don't have a lot of time, we're going to put in 5. We're going to put in 5 chemicals in our comet. Okay, you got that? 5. Yeah. Oh, I see a hand. What's the hand up for? I got 7 fingers. 1, 2, 3, 4, 5, 6, 7. I do. All right, whose turn is it? Your turn. I know you're excited. There's the people here, but it's not your turn. You got to wait your turn. All right. There you go. All right. There's 5. My dad said you can always talk to yourself, just never lose the argument. All right. So I don't have to worry about that. So we're going to put 5 chemicals in our comet. The number 1 chemical, or the number 1 thing in our comet, is a thing called rock. Rock. Meteors. They're called meteors, but we call them rock. Not dirt. Dirt's got dead things in it, live plant matters and stuff like that, but rock. All right. And I'll see here and pull in here. I don't know if you can see that. See that? That's rock. Right? Rock. That's the stuff. That's what most of the comets are made out of. Now, what I'm going to do is show you. Anybody ever go outside and see a meteor or a streak of light, a shooting star? Somebody might know what it is? Raise your hand. Oh, okay. All of those of you who didn't raise your hand, put down the TV, turn off the video games, and go outside and look up, because you'll see a shooting star. Now, that shooting star was caused. See that little bitty rock? That's actually a pretty big meteorite, but that's a big meteor. But that shooting star was caused by that little rock as it hit our atmosphere. You're going to go, Mr. Science Guy, how can that little rock cause that big streak of light I saw in the sky? Well, I'm going to show you. I want everybody to put their hands together like this and go, huh! Wait a minute. I said, put your hands together like this and go, huh! There you go. All right. Now rub your hands together. All right? Rub them faster. Now press harder. Really hard. Ow! That got hot. Wait, it got hot? All right. Ooh. Smells like bird flesh. All right. That is friction. Press them really hard, rub it fast. That's friction. That little rock, when it hit the atmosphere, friction causes it to turn to plasma and we give us a meteor. Now, you say, what? There's nothing out there. Wave your hand back and forth. You feel that? That's air. You're creating friction. Your hand is waving through the air and you're hitting it. And that's why you feel that wave, that breeze on your face, okay? That's how we get our meteors, and that's where the meteor showers come from. Now, the second most plentiful chemical in a comet is ammonia. It's not ammonia. Sorry, don't get all excited. Don't raise your hands up yet. It is methane. Methane on our planet is a gas. It's very explosive with oxygen, so we can't use methane. And what I do is open it up. They're over there taking a picture. It'd be an explosion. My hair would be on fire. My house would burn down, and they'd never invite me back. So we can't use methane. And y'all know where methane comes from, right? No? Okay. Beans, musical fruit. The more you eat, the more you make methane. All right. So the next most plentiful chemical on the list of a comet is a thing called, not ammonia, called hydrogen cyanide. Wait a minute. Hydrogen, ooh, that's a big word. We'll have to take a look at that. Hydrogen cyanide. Let's see. Oh, I know what hydrogen. Hydrogen is that thing we make in chemistry class. We touch it with a match and it blows up. Those of you who might know the Hindenburg and some of the other things and some of the other people, they blow up these big things. Those are hydrogen gas. So it blows up really good. That's why I have no hair, because I blew it all off. All right, burned it all off. Now I'm thinking cyanide. What's cyanide? Oh, I saw that in a movie once. It's basically really bad for you. It kills you. So if it blows up and it kills you, it's got to be really, 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 very, really, 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 really bad for you. All right. Question. See who was observing out there. How many varies did I say? Nope, not 5. Nope, not 10. Nope, not 7. I said 1. I said really, 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 very, really, really, really bad for you. Good job. Keep observing, though, folks. Keep observing. We'll get to do it here in a second, okay? So the next one after hydrogen cyanide is the thing called ammonia. All right. Now, anybody ever smelled ammonia? Well, don't smell ammonia. Woo! Real nasty stuff, man. Real nasty stuff. Okay. So don't smell the ammonia. Just look at it. Now, ammonia is one of the chemicals that's found in the comets. It's also found in a lot of planets, a lot of things here on the Earth. A lot of plants use ammonia nitrate, and stuff like that for nitrogen, for the fertilizer and stuff. So, all right. Now, I figured out that occasionally, I'll be the first one to tell you, occasionally my comets blow up. Right? When I'm making a comet, they blow up and they go everywhere. And everybody goes, my eyes, you know. All right. So if it starts smoking and hissing and bubbling, all right, it means it's going to blow up. And I'm not going to yell, run, it's going to blow up, because there's nobody here. I would just be the only one that got blew up with it. So I'm not going to do that. Okay. Right? So what I'm going to do, you know, and I'm not that crude either. So I'm going to go, hold this a second. I got to run out to the car. I forgot something. Okay. So then it blows up and you lose the eyeball or the finger or whatever. Okay. So we don't have to worry about that. All right. Now, the problem with ammonia is it just takes a little bit. All right. But in fact, it only takes a little capful. All right. Now, the problem with that is, like I said, I'm so scared about it. It's like I burnt my hand one time on the stove. Well, I won't touch the stove again because I'm afraid I'm going to burn my hand again. So they usually get a volunteer from the audience, but there's no audience here to volunteer with. So I'm going to have to do it myself. So bear with me while I center myself and pour this in there. Okay. Sorry about that. I got to just hold it gently. Just pour just one little bit, not much. All right. Kind of go with it. All right. Just pour a little bit. I just want a capful. All right. Will you have a question? Uh-oh. I think I put too much in there. Oh. Well, if it starts smoking, hissing, bubbling, you know, I'm going to leave. You guys can watch my room blow up, and we'll come back later and clean up the mess, okay? All right. Now, the third most plentiful chemical in a comet is the thing called polyaromatic hydrocarbons. You can't see that very well, but it's a really sick-looking blue, okay? Polyaromatic hydrocarbons are long-chain molecules. They're so long that 3,000 of them will fit between those two fingers as hard as I can squeeze them. That's how big they are. That's pretty big, all right? Polyaromatic hydrocarbons are found in giant clouds in outer space. They're found in plants, animals, people, bugs, aliens, anything, viruses, anything that's alive, okay? In fact, we think that's where they came from. The clouds of outer space, when they made our solar system, is where polyaromatic hydrocarbons. They're an essential part of life too. Now, if I could go out into outer space and gather this much polyaromatic hydrocarbons up, or PAWs, okay, this would be worth tens of millions of dollars, and I wouldn't waste it making a comet. Actually, you know what? I'd waste some of it making a comet because, hey, I'm 60 years old. I can't spend $10 million. So I would do that and have fun with the rest, okay? Now, since I can't go out in outer space and get some polyaromatic hydrocarbons, I had to come up with an idea, and I had a brain fart. No, that was the methane. I had a brain aneurysm. No, that was a hydrogen cyanide. I had a thought. If it's found in everything alive, it's probably found in everything. That's right. Dead. Good job. Found in everything dead. So before my programs, I walk around the house and I look around and I go, There's some bugs over there, some dead bugs, June bugs, things like that. I pick them up, throw them all in the blender, right? I look around, and if I'm really, really, really lucky, I'll find some stink bugs, because we know they got to be full of polyaromatic hydrocarbons because they smell so bad, right? I'll throw them in the blender too. But if I'm really, really, really lucky, I'll find a mouse in a mousetrap, throw it in the blender, add a little water, blend it all up, run it through the coffee filter to get some mouse brains out, and there I end up with polyaromatic hydrocarbons. Now, as I mentioned earlier, that our comet, all right, that our comet's going to be a giant dirty snowball. And you all know with a snowball that if you don't have the right consistency, it won't pack together, okay? So the polyaromatic hydrocarbons kind of hold the comet together, and there's only one way to tell if the polyaromatic hydrocarbons are the right consistency, all right? All right, you got the right consistency. So when it goes in there, you can't see this, but I'm pouring some in there, all right? You have to, nasty stuff. Whoa, almost put my finger in there. That's dihydrogen monoxide, very deadly. So, whew, nasty stuff, nasty stuff. The closest thing we got to our planet on something like this on our planet for this comet is like maybe think motor oil, a little gasoline, long chain hydrocarbons, stuff like that. That work fine. Okay, so that's what I use, polyaromatic hydrocarbons. Okay, now, sorry about that. Okay, now the fourth ingredient in my comet, the fourth ingredient in my comet is a 1, 2, 3, 4. 1, 2, 3, 4 is a hammer and a glove. 1, 2, 3, 4. A hammer and a glove. A hammer and a glove? Look, if we find a hammer and a glove on a comet, we got bigger problems than just what we think is going on. But a hammer and a glove, what's it for? Oh, the hammer and the gloves to remind me to put on the glove. So when I reach over here into the box and pull out a chunk of frozen carbon dioxide, it won't burn my hand. All right, so I put my glove on. I've got the frozen carbon dioxide in my hand. I'm throwing it up and down, so I'm not going to worry about it, okay? What? Somebody has their hand up. What? I didn't put the glove on. I did. Ow, no wonder. Ow, no, okay. Well, let me put the glove on, all right? Let me put the glove on here. I don't want to burn myself. Right there, I got my glove on, okay? And then I pick up the dry ice with the glove, and I start throwing it up in the air again, okay? Ow, why is it hurting me? Oh, that's right, because I put the glove on the wrong hand. Okay, thank you. Okay, now this is frozen carbon dioxide, right? Some people call it dry ice. Well, if I put it in here, it's in a bucket of water. It's not dry, okay? We'll talk about another program when we talk more into chemistry and stuff, what dry ice is, what it is. But we're going to use frozen carbon dioxide. Now, I don't know if you guys can see this. As I throw it up, do you see a little bit of smoke or gas coming off of it? Okay, all right. Now all I'm gonna do is, did anybody see it come down? Where is it? Do you have it? See where it went? Oh, there it is. I dropped it. Oh, good thing, huh? Good thing. All right, so I'm just gonna put that in there for right now because I don't want to play with it again. Now, we're gonna add our fourth ingredient, which is frozen carbon dioxide. All right, now, I have to borrow my hat a second because I'm going to fill it up. Now, I used to do the hat, use the hat that I put on because I quit doing that because I get brain freeze. And I don't want to get brain freeze, right? So I'm just going to grab a bunch of frozen carbon dioxide, put it in my hat, and crush it up, all right? Crush it up. Excuse me a second while I go down here. I'm still here. Don't go away. I'm down here. All right. Ignore the man behind the curtain. Batteries are not included. No animals were hurt in the making of this comet because they were already dead. And the views of this astronomer is nowhere related to the views of the people who are running the program to do this. All right, there we go. Ha. All right, so I'm going to dump my frozen carbon dioxide in here. Turn my hat inside out so I don't get brain freeze. All right. Good. All right, so I'm going to put my hat back on. Right. Put my hat back on. I don't want to get brain freeze because I got to be careful. There's frozen carbon dioxide in there. You see, when I get brain freeze, I get stuck. I get stuck. Oh, sorry, man. Brain freeze. I warned you about it. Oh, look. There, I got to get the rest of those out of there. A couple of big chunks still in there. Okay, back to that. Now, I'm going to mix my comet up. I'm going to put shake my comet all about, put my left foot in, my right foot out, and shake the comet all about. Wait a minute. Let's shake it all about left foot. That sounds like a song. What song was it? Yes. Hey, the Hokey Pokey. Good job, good job. Oh, wait a minute. I did something wrong. What did I do wrong when I was doing the Hokey Pokey? No, yeah, nope, that wasn't it. Nope, that wasn't it. That was it. I said put my right foot out and my left foot in. And by the way, my left foot's over here, so I put it out. Hey, good job, good job. Okay, now I mix my comet all up, and when I'm all done, I end up with a giant dirty snowball. All right, now that doesn't look like a giant dirty snowball to me. It looks like some rocks and ice. Huh? What happened here? All right, now remember we're talking about being an observational scientist, okay? Well, as an observational scientist, basically a lot of scientists do research. My definition of research is if we knew what we were doing, it wouldn't be called research, right? We're doing a lot of research tonight, okay? The other thing is, now I know everybody, a couple of people who out there have had some failure, right? Failure, yeah. Added something wrong, did something wrong, something like that, what we call failure. Now to me, you need to turn that way. Failure is just an unplanned result, all right? It's an unplanned result. Tonight, we're doing a lot of research with unplanned results, okay? So, why didn't it work? Anybody know? Yes, you. Nope, that wasn't it either. Nope, more ammonia. Nope, that's not it. Nope. Polyaromatic hydrocarbons, not for those. Okay, that's right. How many things did I say I was going to put in a comet? 5. How many did I put in there? That's right, 4. That's why my comet didn't work. Aha! Smart person. Okay, now, reason that is I saved the most deadliest chemical, the most dangerous, most destructive chemical for last, okay? This is dihydrogen monoxide. Dihydrogen monoxide, very deadly chemical. It is so destructive that it can destroy entire continents. It breaks down everything. Too much of it will kill you. In its solid form, it'll crush you like a pancake. In its heated form, it'll melt off flesh from your bones. It is so destructive. Too much of it will kill you. Strange thing is, too little of it will kill you too. Dihydrogen monoxide, that's one of those big words. So let's take a look at the thing, what he's trying to do here and go. Dihydrogen monoxide. Let's break that word down. Dihydrogen. Di means two hydrogens, okay? Monoxide. Mono means one. What is 2 hydrogens and 1 oxygen? Nope. Yeah, what's that? No, that's not it either. No, it's not water. You're close though. Yeah, right. That person right there. H2O. Now, some of us call it water, but the water we have around here has got other things in it. So we called it H2O. 2 hydrogens, 1 oxygen, H2O. Now, what I do is because when I pour this in here, I got to put the correct amount in here, or just another reason why it sometimes blows up is I drew a straight line at the bottom of that cup. Can you see that cup? See that straight line in there? Okay, all right. So I've only got to be able to put in 235.7964321 milliliters of dihydrogen monoxide. All right. So I have to be very careful to make sure I put this in here just in the correct amount. All right. Now, what's that? Your question? Oh yeah, I'm actually, when I'm not doing this, I'm Skip Bird to ScienceNerd.com. I missed a cup. Oh well. All right. So, all right, now what we're going to do is we're going to simulate gravity. So I'm going to pick this all up. All right, I'm going to simulate gravity. And occasionally, though, I forget what I'm doing, you know. Instead of talking, I'm simulating gravity, things along those lines, and I'm going, what's going on? Oh, no, boom! Woo! All right, so we got that. Uh-oh. It's hissing. It's smoking. It's bubbling. Hold on a second. I'll be right back. I got to go out to the car. I'll be right back, okay? I'll be right. What? Oh, okay. All right. Since there's nobody else here, I don't guess I have to worry about that. All right. So I'm not going to do that. So what I'm doing is I'm simulating gravity. Woo! Also simulating a, what's that little Scottish instrument? Bagpipes. Simulating bagpipes. Okay, all right, now. Whew, man. All right, there we go, there we go. Okay. Oh, man. All right, we're almost done here. You know, over the years, I've lost a lot of things, okay? I've lost my keys. I've lost toys. I lost my homework one time. Actually, I didn't lose my homework. The dog ate it. Look, they found out I didn't own a dog, so the dog didn't eat it. But so kids, don't tell your parents or the teacher that you lost your homework. The dog ate it. They know better, okay? But oh, and I even lost my kids once, but luckily they found their way back. Hi, he's over there. He says hi. Okay. Now next year we're going to the Grand Canyon to see how well they do there. Okay. All right. Now, the thing over the years, you know what I missed the most of all the things that I've lost? You know what I missed the most? I missed my mind. All right, my mind. See there? I carry my own little brain with me. All right. Now, when we all lose our mind together, I have an advantage over everybody else because I labeled my mind. I put my name on it. It's a bird brain. It's a bird brain. So when we all lose our minds together, I can find mine. Right? The rest of you are on your own. Sorry, that's a little joke. All right, now I'm going to put the glove back on. Right. I'm going to put the glove on. I'm going to get ready to bring it up here. All right. Now, I'm going to have my son turn off the lights in the room. All right. All right. All right. He's going to turn off the lights in the room. Turn that one off last. Turn this one off. Okay. So hold on a second here. He's going to turn off the lights. All right. I told you this wasn't a big high-tech production. Voila. There is our comet. Notice it's glowing green. All right. It's fluorescing. In space, hydrogen cyanide and some of the other chemicals fluoresce in the sunlight. Okay. But you can see it's fluorescing. All right. Look at that. That is our comet. All right. Okay, you can turn the lights back on, please. Just those two. Okay. All right. And we're that one. Yeah. Okay. All right. All right. Sorry. Production values. All right. But this is our comet. See our giant dirty snowball? Okay. If you listen carefully, you can hear it hissing. You look closely, you can see it's smoking, and occasionally it breaks. It might pop and go boom. All right. So you got to be careful with it. All right. And that's a giant dirty snowball. That's a comet. Now comets can be any size. They can be big like that. They can be big as this. They can be as big as this room. They can be big as this house. A couple of them, Comet Hale-Bopp, was about 10 miles across. All right. And that's bigger than most cities. All right. So they can be that way. The comets can be all kinds of things. And the little rocks and stuff that fall off behind them is that travels through space. It leaves a little trail of rock and dirt. Okay. And that is where we get all of our comet showers, or meteor showers from. Big meteors like this guy here and this guy here, they're individuals. They're little chunks of rock floating around in space. Okay. Now I know you all heard the word where meteor, meteoroids, meteorite. Okay. When I was going to school, I always struggled with that because I could never figure out what the meteor was, meteorite was, meteoroid was. And finally one day I had a professor. He goes, "Yeah, it's real easy." And they all said that before. It's real easy. If you see a streak in the sky, you go like meteor. By the time you yell meteor, it's gone. Nobody else can see it. So but that's how you know that's the meteor. That's the one that burns up in the atmosphere. Okay? And then the meteoroid rhymes with asteroid. So as they're floating around in space, a meteoroid is floating in space with an asteroid, because by the way, there's no size difference, so they can both be either one. Okay. So it could be a meteoroid, or it could be an asteroid, but that's how you remember the ones floating around space. And then the meteorite is the one there's a meteorite. Meteor right there. Meteorite there. Meteor right there. Meteorite is the one that's right there. So meteorite there is how you remember. Okay. I thought that was pretty cool the way you did that. All right. So you looked at that. All right. Good. All right. So we're doing okay. So that's how we make our comet. Now, again, we have a variety of other programs. We have, besides Chicken Little is Right, we have programs called Light. That's all astronomers get. How big is big? How far is far? And how small we really are. We got Light is All You Get parts 1 and 2. We got Fun with Physics. We got Why Newton's All Wet. I mean, we got a whole bunch of programs that you can get a hold of us and we can take out and do. All right. So basically, one of the young ladies, Jenna, I guess, is going to bring Chris online, okay? Or Chris can turn himself on, whichever way. And I'm going to talk to you a little bit about Chris, and then we will proceed with the nighttime observing, right? So Jenna or Chris, would one of you like to turn on your screen? There we are. All right, so Chris, turn on your mute, turn on your speaker. So while he's trying to figure out how to turn on his speaker, because he's out in the middle of his backyard,
Good evening.
he's freezing. Yeah, thank you, sir. Hey, I appreciate everything he does for us. He is graciously accepted being president for another term. All right, he's going to be our FDR president, which means he's not going away till he dies. So he may be president for several years. But Chris is the president of the Westminster Astronomy Club. He's also an outreach person, and he's also is it a thespian or thespian? Thespian, okay. He's also, I'll ask poor Yorick. You should go see him. He's really good at this, okay. So he does all of that stuff. So what I'm going to do is I'm going to turn it over to Chris, and Chris is going to show us some things in the night sky. When we get all done, then Karen's going to come back, and if you have any questions for me or for Chris, we'll answer them at that time. Okay, Chris, take it away.
All right. Good evening, everybody. It's a beautiful, clear winter night. A little bit cold, but it's a wonderful night for astronomy. So tonight I'll give you a little bit of a tour of the night sky. For those that are not familiar with the night sky, I'll give you a little bit of information on how to find things, because astronomy is actually pretty easy. All you have to do is go outside and look up, but it's also kind of hard because space is big, real big, and it's kind of hard to find some things. So I'll give you a few pointers on how to find some things, and then we'll take a look at a few objects. There's thousands and thousands of objects to see in the night sky, but we'll just look at a few of them tonight. So right now I'm going to turn off my lights so you'll see me disappear, because lights are bad for astronomy. But I'll be right back. All right. So I'm going to show you a little bit of what the sky looks like tonight, and then how to find some things. So first we'll start with a little view of the night sky. So this is the night sky from where I live. And first thing you want to do when you're go outside and you're going to do a little astronomy, you want to orient yourself. You want to find, which direction is which, so you can find some things. So first place you're going to look for is you're going to try to find north. And the way you find north at night in the night sky is you find Polaris, or the North Star. So we'll look to the north. Now, Polaris is not the brightest star in the sky, so you might have to wait a little bit after sunset, probably around nautical twilight, you'll start to see it. But it's still kind of difficult to see, especially on a night like tonight with the moon out and the sky is kind of bright. So I'll show you a couple of tips for finding things using asterisms, which are patterns of stars in the night sky. You have asterisms and constellations. Asterisms are just smaller, unofficial ones that people use as guides. So if you've ever tried to find Polaris, or the North Star, you probably look for the Little Dipper, because the Little Dipper, the tip of the handle is the North Star. Of course, the Little Dipper is a little hard to see in a bright night sky also. So usually what you look for is the Big Dipper, which is a lot easier to find. And then you follow the two stars at the bowl of the dipper to the North Star. Of course, right now, this time of year, the Big Dipper is kind of hard, it's kind of low, and it's kind of hard to see. So you might not be able to see it unless your horizon is clear. Notice I had trees in my horizon. So you can also look for a different constellation that's up higher this time of year, which is Cassiopeia. Looks like a M, or depending on what time of night it is or what time of the year it is, it looks like a W. And it sort of points at Polaris. Not exactly, but it's close enough. It'll get you there. So that's how you're going to find Polaris. And then, one once you find Polaris, you'll notice that all of the stars in the night sky rotate clockwise around Polaris. So you'll see all the different constellations. This is Cepheus, this is Draco, small Dipper here, and this is the Big Dipper or Ursa Major. You'll see those rotating around Polaris throughout the night. And it takes, what, 24 hours, and they'll rotate all the way around the North Star. Not exactly 24 hours. It's 23 hours, 56 minutes, 4.0905 seconds, approximately. That's called a sidereal day. And it's about 4 minutes shorter than a solar day, than a solar mean solar day, which is why this constellation seems to change position from night to night throughout the year. So, and if you look straight up in the sky, you'll see tonight, let me move this in there. You'll see tonight in the, put my directions up, in the east or in the southeast, you'll see the moon pretty high in the sky. A little bit almost due south, you'll see Mars right here. Nope. Keep hitting the wrong buttons. Throughout the night, you'll see these constellations and the stars move across the sky. They'll rise in the east, and they'll move across, and they'll sit in the west. Here you have Pegasus, Pisces, you have Perseus, and Auriga, Taurus, Orion, Gemini. And then early in the morning, you'll see Leo coming up, and Hydra. This is Monoceros. But for tonight, we're mostly going to take a look at what's in the east. Got a few things coming up in the east and then the southeast. In this view, you'll notice a couple of things. Right down here is Sirius. That's the dog star, brightest star in the night sky. And then over here, you got Gemini. That's the twins. That's almost due east right now. And this one, I'm sure everybody can recognize. This is Orion. And it's probably the most famous constellation of the winter night sky. And it's probably the easiest one to see, even easier than the Big Dipper or any of the other constellations. You probably heard of this star. It was in the news a little while ago. This is Betelgeuse. It was dimming, and everybody was wondering what was going to happen. Thought maybe it'd explode. It may explode sometime soon. Well, it will explode sometime soon, sometime in the next million years or so. Well, we're not sure when. This is Bellatrix.
Oh, they're showing the constellation that we looked at the other night.
Yeah.
Yeah.
This is one everybody loves, Orion. And this is Rigel. Betelgeuse is a red supergiant. It's huge. It's about almost the size of the orbit of Earth right now. Actually, it's almost the size of the orbit of Mars. And this is Rigel. It's a blue giant. This one is safe. And these three in here are the belt of Orion. But those are Mintaka, or the middle one is Nilam, and this one is Mintaka. See, these are the belt of Orion. And then you see these stars coming down here is Orion's sword. And there's a nebula in Orion's sword that is pretty impressive, and we'll look at it in here just a second. What it is a star forming. It's a region where with very young stars,
And like a presentation.
clouds of gases.
Here's the three stars. Remember looking at them in a row?
Mm-hmm.
That's it right there.
Yeah, I remember that.
And this is a cluster of very young stars.
Chris, let me interrupt you a second. Sorry. DeSwan, make sure your speaker's on mute, please. Your microphone's on mute. Thank you. Sorry, Chris.
No problem. And I'll give you a little view of what it looks like. Let me see. All right. So this is my telescope. I have a camera on it. And let me see if I can center this a little bit. So this is the center of the Great Orion Nebula. It's called Messier 42, or the Orion Nebula. And you'll see in the center there's 4 little stars in there, sort of look like a trapezoid. That's called the trapezium. These 4 stars in here. Those are very young stars. They're only a couple million years old. And this doesn't look very impressive right now because all you can see is a few stars in there. But we'll take a longer picture of it. And let me see. Maybe we'll take 10-second picture of it. So a lot of the pictures, if you've ever seen pictures of from the Hubble Space Telescope and things like that, you'll notice that they're very detailed and a lot of color in them, but those are actually very long exposure photographs. So if you're looking at objects in the night sky, you generally don't see much there, not much color, unless you get a long exposure photograph. So now there's a 10-second photograph of the Orion Nebula. And you can see those 4 stars in there, the trapezium. They're a lot brighter. And you can see some of the colored gas around that those stars have formed out of. Now you see the different colors in there. Most of the red gas is hydrogen, it's ionized hydrogen, because that's primarily what the universe is made out of, is hydrogen. And most stars are primarily hydrogen, a little bit of helium. The other colors in there, the blue-green is usually oxygen. You'll find a bunch of different chemicals in these molecular clouds that these stars form out of. Does anybody have any questions? Put them in the chat, and we'll try to answer them. All right. So that's Orion, probably the most prominent constellation in the sky tonight. And then we'll also take a look at, just to the up above Orion is Taurus. And you'll see in Taurus, there's a couple of very nice objects to look at. The Pleiades is right up here. And it's a fairly young cluster of stars. You can generally see it with the naked eye or with binoculars, without any telescope or anything like that, but probably not tonight, because right in the middle of Taurus is the moon. And the moon is very bright. So the moon kind of ruins astronomy for everything but the moon, but a lot of people like the moon. So if you like the moon, tonight's your lucky night, because we're gonna have a look at the moon now. So let me see if I can, I'll switch back here. Now I gotta move my telescope to the moon. It'll take me a second though.
Hey, Chris, it's Karen.
Yep.
All right, we're starting to get some questions, so I thought, maybe this is a good time to start giving them to you.
Sure.
So we have a question about Betelgeuse.
Yep.
So how many light years away is Betelgeuse?
So that's actually an interesting question. You don't know exactly how far away it is, because it's so you may have heard that there's a satellite called Gaia that went up a few years ago and is very precisely measuring the distances of stars and things like that. But Betelgeuse is too bright, so it can't measure it properly.
Oh.
So there's estimates, but they vary widely. So, and they don't really know exactly how massive it is either, because in order to determine the mass, then they would have to know how far it is. They know how bright it is, but they would have to know how far it is in order to determine the mass. But it's probably around 1,500 or so light years away, and it's probably around 20 solar masses. So 20 times the mass of the sun.
Wow.
And the mass is going to determine how long it lives and when it blows up. So that's why there's a little bit of, nobody really knows exactly with the Betelgeuse.
Okay. Have you ever seen Leo in the morning?
Leo will be coming up. We'll be starting to rise about around midnight, or probably a little bit before midnight. And probably early in the morning, you'll see it fairly high in the sky.
Okay.
So if you're an early riser, this good time of year to go looking for Leo.
Someone's asking about Virgo. Can we look at Virgo?
What's that?
Can we look at Virgo?
Virgo's not up now, but
Okay.
yeah, that's more of a spring constellation.
All right, wait a second. Okay, let me see. So my daughter is asking, does your program allow you to look back at Earth at all? Can we do that?
It will. You can do the change the view. Let me see here. So we change our location. We can change it from Earth to, let's go to the moon.
Okay, seems like a logical place.
So we're gonna go to the moon, and then we're gonna change this to moon.
And I want to ask people if they'll be patient because to show these things is taking a little time. So it might take a while before we get to your question. I just wanted to share that with people so they know where we're at.
So this is what the Earth looks like from the moon right
So
now.
there you go. I think this is not sure from Vanitha. You can see what the Earth looks like from the moon.
Yeah.
Chris,
And
explain why the Earth looks like it does.
well, so a lot of people. So when you look at the moon, you notice that it's never in the same place, and there are some nights you can't even see it. But if you were on the moon is tidally locked to the Earth. So the same side, same face of the moon always faces the Earth. So even if we speed up the time, you're still going to see the Earth all the time. It's never going to set. It's never going to move. It'll always be there. The phase will change a little bit. Well, it does wobble a little bit. But you would always be able to see the moon or the Earth from the surface of the moon, and it wouldn't change position very much at all.
Okay, so Ariana McFeeters, actually, I'm going to answer this one, guys, because Ariana has a telescope and she's got no idea what to look for. I want to tell her that Ariana, under normal circumstances, when we have in-person programming every year, we have at least one program that's devoted to the telescope. And we encourage people to bring their telescopes, and we have volunteers who will help you learn how to use them. And in fact, that was going to be the first program in April when we had to shut down for COVID. So as soon as we're back in person holding events again, we'll have an opportunity for you to bring your telescope and have somebody help you learn how to use it.
You can also contact us, and we'll basically have you set your telescope up in the daytime and show you, make sure, looking through with your, showing us what it looks like with your phone and everything, so we can help you get it set up and running even during the pandemic portion of it. But yeah, the best way is wait until we have a virtual or a live program, and then bring it out and we can help you. But we can help you either way.
Yeah.
And most of the astronomy clubs in the state, if there's one that's nearest you, contact them, and there will always be people willing to help you out too. So
Yeah, I have to tell you, astronomers and amateur astronomers, I think of you as the same thing really, are like the most helpful people there are. And all they want to do is share that enthusiasm for looking at the sky. So Carrie asks about using the telescope to look for shooting stars. And my understanding is it's really not something that you would normally use a telescope for.
nope, they move way too fast for a telescope. People do have cameras they'll set up a camera with a fisheye lens at night, and they can catch meteors that way. But a telescope has a very narrow field of view. So this telescope here has a field of view it's probably about half a degree wide. So the moon is about half a degree. So that's what the field of view of this telescope is right now. So a meteor flying through that very small area would move very fast. You'd never catch it.
Yeah. Okay. Can you see are there any asteroids you be able to see through your telescope?
There are quite a few large asteroids. Ceres is usually pretty easy to see depending on what time of night it is. On a night like tonight, like I said, the moon is out and the sky is bright, so it's not the best night for hunting small dim objects. But on a dark night, it's actually pretty easy to find them.
Okay. Can you see, so Emmy asks, has a star ever exploded? But I think really what we're looking for is, can we see evidence of an exploded star through the telescope?
You certainly can. So, matter of fact, let me show you something. I took one. Let me just reset my thing here. Let me just restart this. So there's a supernova remnant in Taurus. And I took a picture of it just a little while ago. It doesn't look very nice because the sky is too bright, but I can show you what it looks like in the stellarium. It's called Messier 1, and it is called the Crab Nebula. It's very small and it's very dim, but this is what it looks like. This is a supernova that exploded in the year 1054, 1050. I think it was 1054, 1051. something like that, pretty close. You have to look it up. It's very close to around 1050 something. But it was actually on the 4th of July. It was observed by Chinese astronomers, and it left this remnant here. So you got a lot of gas and dust in this area. There's a pulsar in the center of it, which is a very fast spinning neutron star that sends out radio waves. And there's actually several of them that you can see in the night sky. This is probably the most prominent one though. And it was in I think 1054 is when it exploded. We haven't had a supernova in the Milky Way for a very long time. There was one in the Small Magellanic Cloud in 1986, I think, something like that.
1987.
87, yes. So that was the closest one recently, but you can see them in other galaxies quite often. If it was in our galaxy, it would be real bright, and you wouldn't miss it. And when Betelgeuse explodes, you'll know it. So
Yeah, that's what they were when Betelgeuse was doing all those weird things.
Yeah.
The biggest planet, so that would be
the largest planet is Jupiter.
Jupiter. Can we look at Jupiter?
Jupiter's down, so
Oh, okay.
yeah, it won't be back until March, April, something like
Yeah,
that.
I was gonna say we usually get some really good views of Jupiter.
Yeah.
So,
Yeah. Just recently, well, we had the conjunction of Saturn and Jupiter just recently.
right.
It was very low on the horizon then. So, and now it's up during the day and it sets before the sun goes down. So can't see it now, but in March or so, it'll start coming up in the morning. So you'll see it before the sun rises.
Yeah, if you go to a website called spaceweather.com,
Yeah.
they actually had a picture of Jupiter and Saturn near the sun taken by one of the spacecraft. They're really good to see use them. I use them a lot to go see what's coming up in the night sky,
Yeah.
what's up there, what's going on that day. They also show some meteors, meteor showers, stuff like that, asteroids. So if you want to know what's going on in space, spaceweather.com is the place to go.
That's great tip.
And
Can you see Scorpio, Chris?
Scorpio's not up yet either.
No?
That's a
Okay.
summer constellation. Now here's in case you didn't believe me that you can see supernovas, here's one. That's the Crab Nebula. And you'll
Okay.
notice, of course, that it's the sky background is very bright and you can't see it very well.
Yeah.
And that's because the moon is right next to it.
Oh, okay.
So-
Somebody's asking about Capricorn. Is that visible now?
Capricorn's not up either.
Okay. So it is interesting. People should know that depending on the time of year, it depends on what you can see and
And also what time of night. Hey, Chris,
and what time of night too, which is
Yeah,
what, so for instance, in the summer, when we do our Perseids program, we go into the wee hours of the morning, just so people can see something.
Yeah.
Um,
So these are the
What are-
constellations that are up
so
right now.
I have a question. What are the different twilight? You mentioned one, but I know there are a few different twilight times.
Yeah, so if there's a couple of websites, you used to be able to go to U.S. Naval Observatory and get the sun and moon information, but they've been down for a while for upgrades. But I think there's a few other websites that you can probably find that'll tell you the times of sunset. I think it's around 17 something, 1715, 1720, something like that right now, or that's 520. It's not exact, but then after that, they have what's called civil twilight. And that's when, officially, that's when the sun, at sunset is sunset, sun goes down below the horizon. Civil twilight is when it's 6 degrees below the horizon.
Okay.
And that's when it's starting to get dark enough to where you can start to see some stars. Nautical twilight is when it's 12 degrees below the horizon. And that's when it's getting pretty dark. You can still generally see the horizon when it's nautical twilight, but you can see most of the stars. And then they have astronomical twilight, which is 18 degrees below the horizon. And that's basically when it's dark. So that's the one astronomers like because the sky is all dark and you can start to see a lot of the dimmer objects when there's
Okay.
not a moon up.
So I have a question from Grant, age 4. Why does the moon reflect the sun's light?
Ah, well, it's because pretty much everything reflects light unless it's black. So depending on how dark the material that the planet or asteroid is made from depends on how much light it reflects. And they call that albedo. That they have different levels of albedo depending on what the body is made of. And the moon is pretty light colored, mostly rock and stuff like that. So it reflects the sunlight just like the Earth does, or just like every other object in the solar system does. There are some asteroids that are very dark colored, and you don't see them, and it's very difficult to see them because they have a very low albedo. But most things reflect the sunlight fairly well.
That's great. So Benita's daughter is asking, boy, these are some deep questions.
Yeah.
How old are stars?
So it depends. There's some stars that are very old and some stars that are very young. That's a relative term. Very young means a couple million years old. But very old means billions of years old. And the stars that are very large, the massive stars like Rigel and Betelgeuse, they burn fast and they burn bright and they don't live very long. So some of those very large stars, they live only a few million years before they explode. Some of the star the size of the sun, which is a yellow dwarf, has a lifespan of about 10 billion years. And it's about half over right now. So in about 5 billion years, it's going to, actually about 4.5 billion years, it's going to expand like Betelgeuse and then collapse into a white dwarf. So, that won't be good for Earth, but we got a few years left. There's some the red dwarf stars that live for trillions of years. So it just depends on how massive the star is, depends on how long they live.
Okay, a lot of people are asking, so more than one person is asking what kind of telescope you're using and also what the program is that you're using.
Okay. So this is the software is called Stellarium. It's a planetarium software and you can download it for free on the internet if you just search Stellarium on the internet. And it's pretty easy to use. It's very good software if you want to use it to plan astronomy observing, so you can find things that are up before you go out at night. As far as a telescope goes, what I have here is a Schmidt-Cassegrain telescope. I'll turn the light back on. You can sort of see it. That's the Schmidt-Cassegrain telescope. You notice it's pretty short. It has a focal length of 2,500 millimeters or 2.5 meters, but you'll notice it's a lot shorter than that. And the reason it's shorter is because it has a folded light path. So that when the light comes in from the top, it goes down to the back to a mirror, and then it goes back up, reflected back up to the top to another mirror, and then it goes back down through the focuser to the camera. So it makes it a lot shorter, makes it more compact, but still has quite a bit of focal length on it. This one's a 10-inch mirror, so that's the surface or the diameter of the mirror, and that determines how much light it will collect. The focal length determines how much magnification you have.
Okay.
And it's a Meade LX200.
So what is the brightest star was the question, but I think maybe it's more like a category of stars, right?
What's that?
The brightest star.
So it depends on what you mean. The brightest star that
So
is
I'm thinking like,
current magnitude.
what category of stars? So you were talking about our sun was
Our sun is what's called the yellow dwarf.
a yellow dwarf. So thinking about the different categories of stars, which would be the brightest?
So they have different categories that they spectral classes. They're given letters, and they're not, for strange historical reasons, they're not in order. And it's and I forgot the order of it. It's A stars. O and A stars are the brightest, the hottest stars, and M stars are the dimmest and the smallest. So, and there's a bunch of them in between there. The sun is a K. I think it's a K. Yeah, but they're classified according to their spectrum, how hot they are and how bright they are. And the hotter stars are bluer stars, and the cooler stars are red stars. So Rigel in Orion is a blue giant, so that's a very hot star. It's a big and bright, and then smaller red dwarfs are very cool, are a lot cooler. But as far as the brightness goes, it depends on how far away they are and how hot they are. So it could be a close star and not very hot, but it would look brighter, or it could be very far away and it could be a lot brighter, but it wouldn't look that way to us. The brightest star in our sky is Sirius right now, which you'll see coming up in the east.
Okay. Right. This question I actually don't quite understand. I hope you do. Are you able to see Cooper out in the wormhole?
Now, I don't know. I don't think I know anything about Cooper.
Yeah, okay.
That must be something the kids know.
So, I think we're coming to the end, but a lot of people want to see a planet again. I don't know. Can we look at Mars again?
Yep.
And we'll sort of end looking at Mars. How does that sound to you?
All righty. So, and this is the moon. I'll see. I'll bring it over onto Mars. Let me see. Solar system.
You got to share your screen again.
Oh, yeah.
While he's doing that, Skip, did you have any things happening with Westminster Astronomical Society you wanted to share?
Yeah. We have a variety of programs coming up. If you just go to our website, excuse me, westminsterastro.org, or just look for Westminster Astronomy Club, and it'll take you there, and you just go to our calendar of events. We have guest speakers. In fact, this coming February, we have a special guest speaker from England. We're doing it virtually, so it actually starts at 4:30 in the afternoon instead of our normal 7:30 time at night. So if you go to our website, it tells you all about it, and they'll have links there to click on and join whenever necessary. Okay.
Okay.
The other thing is mainly just go outside. Any clear night, go outside and look. Like right now, you can go out and see the moon. You can see Mars. Okay. You don't need binoculars. You don't need telescopes for those. Go out there and look at them. If you have any of those, it's even better. But it's really cool is to go outside and look at how the moon changes every night, where it's positioned compared to the other stars like the moon or Mars and stuff. Even like we saw with the conjunction back in December of Saturn and Jupiter, how they were close together in our night sky. They're 400 million miles apart, okay? But they just happened to line up to us before they went down to see that early in the morning. If you're like me and you get up, 5:30, 6 o'clock to start work, you can go outside and you can see Venus out there, all right? Venus is a very bright star, all right? Very bright planet, sorry, very bright planet. The only thing brighter than it is the moon and the sun. And as Chris was saying also, that the sun is a yellow dwarf. Technically, it's not the brightest one in the sky. It just happens to be the brightest one because it's the closest to us. There are also some sunspots on the sun. So sometimes we'll have a daytime virtual program where we're actually looking at the sun. So again, everything that we're doing, it can be found on our website. And again, as we mentioned before, if you ever need anything along the lines of astronomy, just go to that website and contact us. Thank you, Karen.
Oh, thank you. This has been really fabulous. And so for everybody in the Gaithersburg area who comes to our skywatching programs when they're live, we just got a new telescope, EV scope, which we're going to be able to, we thought we'll be able to do projecting onto a screen to make it a little safer, social distancing sky watching. So hopefully by the end of the summer, I mean, obviously no guarantees, but that's our hope. By the end of the summer, we'll be able to once again have figured out a way to do this in person. So is this Mars?
This is Mars, and it's there's a lot of turbulence in the sky tonight. See, it's jumping around a lot, so
Yeah.
it's not a very clear view of Mars tonight. But
Well, I think that's fantastic. I want to thank, I want to thank Chris and Skip. That was a terrific program. And I want to thank all the people who tuned in to watch it and ask all those great questions, especially all the kids out there who are so interested in astronomy. And I hope we're going to see you in future programs. So bye, Chris, bye, Skip, and hopefully we'll be able to do this again.
Yep.
And tune in on Tuesday at 11 o'clock for Stella Stellar Hair.